Yowzers, and welcome to the Daily Space Weather. We've got lots of stuff to talk about today, including coronal mass ejection and solar flare warning, spectacular imagery of the closest star. Thanks for being spaced out, all you spaced out viewers. We're coming at you from the galactic core today. Here's El Sol in 171 angstroms. Major sunspot groups in the southeastern limb causing a solar flare and coronal mass ejection warning. Major filaments in the northwest as well. Here's your colorized magnetogram. The kind of magnetic fields associated with this sunspot right here, that's sunspot 2887, are capable of producing major solar flares. Here it is in close-up. This is 193 angstroms. Again, at the end of the video, we will have even more spectacular imagery of these sunspot groups. There's actually 3 groups there, and there's another one more in the Earth-facing zone right over here. This is 131 angstroms. Another one of the ionized iron ultraviolet emission spectra. And let's continue on and blast through a bunch of data. 10.7 centimeter radio flux now up to 93. No surprise with all of those large sunspot groups. Here it is in context. The black line is the 1-year chart of the 10.7 centimeter radio flux. The red line is the sunspot number. Quick stop at the Space Weather Enthusiast dashboard to show you 0 NOAA forecasted geomagnetic unrest events or geomagnetic storms, etc. Let's take a look at global seismicity real quick. There was one earthquake very close to the North Pole. That happened at 1747 yesterday on 10/24, October 24th at 1747 Universal Time. A 4.7 occurred quite close to the North Geographic Pole. Anyway, let's scroll up the list. We usually look at this a little bit closer. And we see also a Cascadia zone quake there. Off the coast of, looks like off the coast of Oregon. That was also a 4.7. So a little bit of odd quakes happening here. Not the most common earthquakes you'll see. No major quakes, though. Perhaps some of these are foreshocks. It's been quite a while since we've had a 7+ magnitude quake. There were some deep quakes by Fiji, a 4.5 and a 4.3 at nearly 600 kilometers depth. Also, Indonesia saw a deep quake. That's a 4.9 magnitude. 246 kilometers estimated depth for that. One of the larger quakes of the past 24 was a 5.2 at Papua New Guinea. Also, Indonesia saw a 5.0. That one happened just a couple hours before we recorded the video at 6:52 Universal Time. And check it out, we've got some spectacular webcam imagery here, which we were linked to from volcanodiscovery.com on the Volcanoes Today page. That's La Palma. And as far as I know, that is a live webcam. Let's see what else is erupting. By the way, there's some nonsense on the internet about it. Let me guess, it's a directed energy weapon, right? Anyway, some silly articles going around on the internet. I won't link to them or mention them very much besides what I've already done. You can copy-paste that. They didn't link it, which was probably smart. Sunspots also erupting. No indication of the size of the ash plume here, by the way. At La Palma, flight level unknown. Sunspots flight level 070. It's a 7,000-foot ash plume. Karangatang now back on the list, producing a 10,000-foot ash plume as it explodes near Indonesia. SmAsho exploding in the Aleutian Islands. 8,000-foot ash plume from SmAsho. Fuego exploding. 16,000-foot ash plume from Fuego. Nevado del Ruiz exploding. 20,000-foot ash plume there. Flight level 200. Sangay exploding. Flight level 190. Revenador exploding. Flight level 160. Don't fly an airplane over a volcano, folks. Explosive activity continues at Peru also. The Sabancaya caldera producing a 25,000-foot plume of volcanic ash. Please don't pole vault it. Don't pole vault the caldera, folks. Do visit our links. Check out our high-quality merch. The designs are all poignant and spectacularly high resolution and colorful to impress even your most annoying friends and foes. Today's featured product is Mansa. Make America not suck again. It's up to you, people, to make America not suck again, not giant bureaucracies like corporations that can't even get out of their own way. Who are you taking health advice from? We want to know. Let us know in the comments. Anyway, we hope you're doing all you can to Mansa, and that is make America not suck again. There's also a Mensa product, which is make Earth not suck again. So check them out. They make great gift ideas. We've got everything from throw pillows to mouse pads, laptop sleeves to mini skirts. So check it out, and don't forget to make America not suck again. This nonpartisan message brought to you by smAsho.com. Welcome to the Neo Renaissance. And also, congratulations on realizing that our channel exists. Please support the channel financially, as we're paid just this side of nothing to put the videos on YouTube. You can find the link to our merch shop right on the homepage. It's the smAsho merch link at smAsho.com. Let's look at magnetic data. Since stars could arguably be described as the magnetic fields, yeah, you could say, what is a star? A star is the magnetic fields that are associated with, we shouldn't really call it the magnetic fields. The magnetic fields are a product of their intrinsic properties, but I'm not going to get into that in today's video, as that would be more like cosmology or heliophysics than space weather. Anyway, there's a 3-day chart from the GOES 16 and GOES 17. As Earth is in a North Pole current sheet, I would suspect, right on the edge of the North Pole current sheet. So that's kind of surprising. There's certainly a current sheet transition happening at the moment. It's really been going on all day. Anyway, here's a line of sight view of the same data. Essentially, it also shows you the solar magnetogram. That's why I like to view it daily. You can see this B field moving around. This blue line here represents it's associated with the BZ component of the solar wind. And I'm just going to not explain that fully in this video either. We don't want it to be too long, and we've got more spectacular imagery of the sun. We've got a filament to name also. So here's the line of sight coronal hole plot, and you can see some changes to the sun's B field there. Those blue lines are the sun's B field, the field that goes through the magnet. And here is the coronal hole visual. Coronal holes being the other major feature of solar activity associated with the solar cycle progression, or solar maximum, solar minimum, etc. At solar minimum, we see coronal holes stationary at the solar polar regions. Here's the filament we got to name. You want a close-up? All right, we've got it. So if anybody would like to name that filament, leave us a comment. Let us know what you'd like that filament named. I think I named the last one Steve. And some of that filament arrived at Earth, I believe. So yeah, name that filament. So here's our detected sunspot groups, and we're showing the magnetogram and the intensity gram here. Sunspot 2887 still likely to produce major flares. Sunspot 2888 is a beta-class sunspot group at this point also, at least last I checked. Pretty sure it's a beta-class sunspot group, so we'll see that updated later today as well. Beta-class sunspot groups more likely to produce solar flares as they have more complex magnetic fields. So here's a solar flaring situation, no major flares, which is kind of surprising. We're expecting to see some coming soon. Coming soon and causing a radio blackout near you. By the way, if you want to see some of the effects of solar flares, go to any of these Space Weather Prediction Center pages. Come down here and click on the D-Region Absorption Predictions. That will bring you to the radio blackout data when the ionosphere turns from a re-emitter to an absorber of high-frequency radio emissions. No spikes in the proton flux. No surprises there. We show it daily, as it's one of the most important features of major space weather. Yeah, proton spikes. Let's look at the real-time solar wind here. Fairly unremarkable here, although some variations in the speed. Mainly downward trends in the speed. Current conditions are solar minimum-y with a 5.12 protons per cubic centimeter density and a 334 kilometer per second solar wind speed. BT-BZ is fairly convergent on the zero line there, at least the BZ, with a total field of only 5. I think there's a coronal hole wind stream on the way. Anyway, here's the planetary K index, a measurement of global geomagnetism. Nothing to write home about there, just calm conditions. KP1 is the current situation. Here's the geospace for the last 4 hours. If you want to read about how the data is derived, how the model is created, click on details on the Geospace Magnetosphere Movies page, and you'll have a link to the space weather modeling framework. It's using a lot of variables. Homogeneous magnetohydrodynamic pressure there over the past 4 hours. How about ground magnetic perturbation, since there's a polar excursion going on, which has people moving to bunkers and doing all kinds of utterly moronic things? We show the data daily. So there's 4 hours of ground magnetic perturbations. Geospace delta B changes to Earth B field. Nothing too exciting happening there, again with such a homogeneous solar wind and magnetic fields and so on. Here's a diagram of the solar system. Let's advance it 1 week. Here's where we'll be in a week, approaching another new moon on November 11th. Next, a star chart. It's in -the-sky.org. Mine faces the south. This yellow line is the ecliptic. That's the path the sun will take across the sky. If you're wondering, let's do a cosmology segment. Starting with the apod.nasa.gov astronomy picture of the day, featuring the Trifid Lagoon and Galactic Center. Yeah, the Trifid Nebula, the Lagoon Nebula, and Sagittarius A stars region. Here from Monument Valley, yes. So multiple images likely stitched together there. Some time-lapse photography, certainly, of the road by Michael Abramian. Sorry if I mispronounced your name. It's Route 163, which is practically parallel with the galactic plane. apod.nasa.gov if you want to check it out yourself, apod.nasa.gov. Today's random number is 100, which coincides with a catastrophic variable. Yeah, number 100 on the Neil Gehrels Swift-Bat X-ray Observatory is a catastrophic variable. Yeah, that means it's a star, folks. It's also a Dairy Queen Herculean. It eats a lot of food at Dairy Queen. Anyway, there are the X-ray outputs on it. It's a naughty, naughty star. A naughty, naughty star, which produces a lot of X-ray. By the way, if you click on Simbad, it'll take you to this page right here. And if you click on the CDS portal from Simbad, it'll take you to this page right here. And there is this particular star, known as V star XY Ari. And of course, it's probably got like 55 different names. We have to have a whole ton of different names for every star. It's required. Anyway, there's the photometric points. You can see it's pretty bright across a large part of the electromagnetic spectrum. When we say electromagnetic spectrum, we're talking about electromagnetic radiation. like gamma rays and X-rays and ultraviolet and optical light and infrared and radio frequency. Anyway, there is that star in false color X-ray. Does it show up in ultraviolet? I would suspect it probably does. And I would be incorrect. How about on pan stars? And there it is, pretty dim on pan stars. And I'll bet it shows up on the 2 mass. And there's the infrared spectra, the thermal output from number 100 at the Neil Gehrels XY ARI. It's a little hotter than the surrounding region. That's today's cosmology segment. No charging hazards currently around planet Earth. We saw a little bit of chaos yesterday in the electron belts. Here's a 1-year chart of the electron flux. Here's a 3-day chart of the electron flux. Here's a forecast for the electron flux. It looks like somebody might be agreeing. I think there's a coronal hole wind stream on the way, folks, which would coincide with perhaps this big dip in the X-ray flux right here. That big dip right there, that's probably the arrival of a coronal hole wind stream. Maybe it won't cause any geomagnetic unrest. It all depends on things like polarity of the current sheet and the BTBZ. Here's a diagram of Earth's Van Allen belts. And yeah, we'll let you know if geomagnetic unrest is on the way. Here's an animation of the total electron content. And once again, we are seeing some chaos here over North America, especially. And I believe we're also seeing some ionospheric low-frequency anomalies there. I'll let that play through a second time. Some big GPS errors happening there over places like the east coast of the U.S., the central U.S., and northern Canada. So some anomalies there in the total electron content. Let's take a look at the ionosphere. One slice of it at least. The F layer, located at about 300 kilometers of altitude. There is the F ionosphere layer's vibrational frequency. I think we are seeing some anomalies there as well. It'll be more clear with the anomaly map. Let's bring up the latest image here. This is a little bit tough to look at, folks, especially if you don't understand what you're looking at. You're looking at how fast the molecules are vibrating in those regions, which is largely the bridge between Earth and space. So here's the anomalygram. This is the departure, the anomaly in megahertz from the 30-day median. And we see some sudden pulses of low and high frequency anomalies here over the north central Pacific, right about here. Yeah, those were legit anomalies right there. So there were some sudden big rifts happening there, some big swings in vibrational frequency. What's cool about the anomaly map is it actually shows you a higher resolution than this. It shows you down to the 100th of a megahertz. At least 100th of a megahertz of anomaly. This only shows you megahertz. Anyway, here's the latest image. That's 9 o'clock Universal Time. All right, we've got lots more to do. We did a meteorology segment. It aired before the daily space weather video. Make sure you check that out. Here's the latest imagery from Lermonth. Yeah, Lermonth, Australia's latest hydrogen alpha imagery. It's pretty spectacular. There's lots of stuff going on. There's a coronal mass ejection and solar flare warning in effect. Major sunspot groups have risen in the southeast. Here's the latest intensitygram and the latest magnetogram. Big sunspots with complex fields produce solar flares. Okay, I apologize. That's an alpha class sunspot. That's a beta class sunspot. So this is almost like a smaller version of this. This is certainly capable of producing large flares. So we've got 2 significant beta class sunspot groups there. I'm not going to get hung up on the names of them because those are basically arbitrary. They're just names on a list. Let's take some close-ups of the southern hemisphere. Here's 171 angstroms. And here are no less than 3 major sunspot groups. Here is 131 angstroms. And here's 94. I think that's all we've got. Yowzers. That's what happens when you have 97 tabs open. There's 94 angstroms. More spectacular imagery. Congratulations on realizing our channel exists. Don't forget to press like and subscribe. Tell your friends and foes about us. And may that solar wind be at your back.